So we have been learning how to transform quadratic equations and what the numbers in the equation tells us. So let's just refresh our memory. We have the equation y equals ax squared plus c. The c is going to tell you if the graph is moving up or down on that y-axis. So graph is moving up or down for your c value. Your a value tells you a couple different things. Your A is telling you that you are reflecting. Reflecting means that if you see that if A is negative, then it's reflecting. And then the A value also tells you if you are stretching or compressing. So stretching means that it's getting skinnier. You got to think vertically stretching. So a vertical stretch, if we recall our parent function, this is our parent function here. A stretch is going to make the parent function skinnier, where a compression, so this is for stretching is the red, and a compression, I'll do compression as green, is going to make it wider. So because of those characteristics, when we think about stretching versus compressing, we can look at the actual A value to determine that. So if A is bigger than 1, then you're stretching, or another word for that is narrow. If A is between 0 and 1, then it is compressing. And so when A is compressing, that means that it's some fraction between 0 and 1. And honestly, it's a fraction where you have a smaller number on top over a bigger number on the bottom. So for example, 1/2, or 5/7, or 8/11. You have a small number over a big number. Those are all fractions that fall between 0 and 1. If I had a big over a small, for example, if I had 5/2, this is actually the decimal 2.5, which means that's a number bigger than 1. So this case would be a stretch. So if it's small over big, you have a compression. So let's look at our problems here. It says graph the function and then compare it to the parent function. Well, let's graph our parent function from previously. We know our parent function crosses at 0, 0, and then at 1, 1, and negative 1, 1, and then at 2, 4, and negative 2, 4, and this is our parent function. So, in order for us to graph it, we want to find our vertex. So we just learned in a few days ago how to find our vertex. That's x is negative b over 2a. And in this case, our a is 3, and our b is 0, and our c is 1. So we have negative 0 over 2 times 3. Well, 0 divided by anything, I mean, that's going to be 0 over 6, but that just means that x is 0. So then if I plug 0 in, I have 3 times 0 squared plus 1, which is just 1. So that means my vertex is at 0, 1. Okay, so then what you guys want to do is you want to plug that into a table. So if 0, 1 is my vertex, then I want to go 2 below 0 and 2 above 0. So that means 2 below would be the numbers negative 1 and negative 2, and 2 above it would be 1 and 2. So we're going to use those x values, and then what you do is you can plug those numbers into your equation. Because remember, we have y is 3x squared plus 1. So if we were to plug those in, I'm doing 3 times negative 2 squared plus 1. And when we calculate that, we get 13. And then I do 3 times negative 1 squared plus 1, and I get 4. 3 times 1 squared plus 1 gives me 4, and 3 times 2 squared plus 1 gives me 13. And notice on the chart here how our numbers are the same on each side of the vertex. And that would make sense because it is a reflection across that axis of symmetry. So now all we need to do is plot those points, and then we have our graph. So if we go back up to our graph, I'm going to change my color. So this graph, we'll just make it red. So we have 0, 1 was our vertex. And then at 1, we were at 4. And then I don't know that I can get up to 13 here. So let's just say 11, 12, 13. So at 2, we're at 13, and at 2, we're at 13. So here is our new graph. So then it says to compare it to the parent function. Well, if you look at my parent function, the black, the red has shifted up 1, and that's because of this 1 right here. And then it's skinnier, which means this 3 right here is telling us we are stretching, because that 3 is bigger than 1. So to describe it, we would say that it stretches by 3 and moves up 1. Those are the two things that is happening. Let's look at another problem. Okay, so we have 1/4 x squared minus 2. So what's nice is we know that what's going to happen to our parent function is based on our numbers in our problem, which is the 1/4 and the minus 2. Well, this minus 2 is going to tell us we're going to go down 2 because that's what the C value tells us. Our C tells us if we're moving up or down. In this case, we're going down because it's a minus 2. That 1/4, if you recall from stretching and compressing, it's a small number over a big. So that means that this particular problem is a compression. So this is telling me that I am compressing. So that means it's going to get wider, and it's not going to grow as fast as the parent function does. So let's plot our parent function on here again. So here is our parent function. And then let's do our vertex and our table to make sure that we know how to plot the next piece. So our vertex, we're going to do negative b over 2a. So again, our b is 0, and then over 2 times 1/4. Well, 0 divided by anything means our x is 0. And then I need to plug 0 in to find my y. So I have 1/4 times 0 squared minus 2. Well, this whole chunk right here is going to go away. So that's just a negative 2. So my vertex is at 0, negative 2. And because I have my vertex, now I can make a table of values. 0, negative 2. And then remember, we're going to go 2 below and 2 above my vertex. And my equation was 1/4 x squared minus 2. So now we just got to plug that in. 1/4 times negative 2. Whoops. Don't know what happened there. Sorry. Times negative 2 squared minus 2. Well, this is going to give me negative 2 squared is 4 times a fourth is 1, and 1 minus 2 is negative 1. And then I do 1/4 times negative 1 squared minus 2. Negative 1 squared is 1. 1 times 1/4 is 1/4, and 1/4 minus 2 is negative 1 3/4. And then remember, because this is our vertex, it's going to be the same on the opposite side. So this is going to be negative 1 3/4, and then this one's going to be a negative 1. And that negative 1 3/4 is a little difficult to graph, so we can just graph the other ones just to make it a little easier. So if we scroll back up here, So our vertex was at 0, -2. So I go 0 in the x and down 2. And then at, whoops, that's not right, sorry. Let's look at our points again. So we have -2, -1. So -2 means left 2 and down 1. And then we're going to go right 2 and down 1. And then there is our graph. Sorry, that's not connected very well. So there's our graph. And notice, you guys, it's wider than our parent function, and it's shifted down 2 units. So if we describe that, we're going to say it was compressed by 1/4, and it moves down 2. And that would be the